Well, here we go again. Our afternoon program is about to start, and it's going to start with a topic that seems pretty undigital in a way. Our next speaker is Uli Kunz. He's a marine biologist. He's a diver, and he's doing a lot of really interesting projects, for example, in the Arctic. And he brought some pretty exciting pictures. So what has technology and digitalization to do with science and underwater world? We're going to hear about that. One of the most amazing facts I just heard from Uli himself is that we should be actually pretty happy to have him here, because he was in January pretty close to being swallowed by a whale. He was diving with a swarm of herrings when a humpback whale came by that was kind of hungry. And he was pretty close to that. But he's going to tell us more about it, and he's going to tell us something about how science and diving and his underwater project changed thanks to technology and digitalization. So come up on stage with me.
Thank you.
Give a warm hand for Uli. A little louder so we can attract some more people here. Thank you.
Where's the rest?
The stage is yours.
Thank you very much. So, hello guys. I'm a scientific diver. My name is Uli Kunz. So most of my time I actually spend underwater. So my office is pretty much submerged all day long. And I would like to tell you a little bit of the challenges that we meet when we do research underwater. And of course, we have developed technologies over the years that helped us to do science underwater. But still, it's a pretty rough world. It's not suitable for technology or electronics in a way. And when I tell people that I'm a marine biologist and that I do science underwater and I do diving and stuff and so on, most of the people actually think, and that are pretty jealous and envious, because most of the people think that this is where I am, where I've spent most of my time, just chilling out in those tropical islands and just warming up my feet in the tropical coral world. Well, that's only part of the story, and it's probably not the truth, because I live in Kiel, it's the northern part in Germany, and the Baltic Sea is not very suitable for diving because the variety of animals is pretty low and it's pretty cold. In the wintertime, we can have temperatures to about -1 degree Celsius. It's very cold, sometimes it's even frozen. And in the North Sea, on the western side of Germany, it's basically the same. 1, 2, 3 degrees Celsius, and there are no coral reefs, but there are big animals that I'm going to show you in a few seconds. So to tell you what I'm doing, or what I was doing in January, you probably heard the story already. That is in northern Norway in January, and I spent about 4 weeks in one of those small dinghies that was dragged behind a sailboat, because I wanted to film whales in northern Norway, and I can't be picky about the place where I'm going to see whales, because that's the place where they are. I can't go to the tropics to see humpback whales when there are no humpback whales. So I chose northern Norway because it's the only place where you have a so-called herring run. It's amazing, giant amounts of herrings come together here in this area in northern Norway, and they are followed by the whales. Orcas and humpback whales, they eat herring, and the amount of herring is just unbelievable. It's probably half as big as the whole city of Hanover. It's giant, and millions of tons of these herrings. And of course, you have dozens of orcas and a lot of humpback whales. So this is about -10 degrees outside temperature, and the water temperature was a warm 3 to 4 Celsius. So you can probably see in my face that it wasn't very pleasant. And I spent 4 weeks to have a few minutes with these whales underwater. So whenever you do science underwater, you need quite a bit of tolerance against your frustration. You need a lot of self-motivation to actually tell you every single day, it's worth it, and I'm going to see those animals, and I'm going to do the science. So that might be a good adventure. This is a picture that I took of those orcas, the killer whales in northern Norway. And it was about 2 minutes, and then it was over. And I spent 4 to 5 weeks in this area to film those animals. I work for National Geographic, the German Geo, but also television stations and production companies in Germany. And you can see here on the left side, this amount of herring here on the left side. And one day I was just basically engulfed by one of those big schools of herring that was 50 meters high and about 100 meters long, and I couldn't see a single thing. The visibility was about 50 centimeters, because then there was this wall of herring. And what then happened, I can't recall quite easily, because there was a humpback whale that basically opened its mouth and tried to swallow the whole swarm. And I was right in the middle of it. He basically pushed me to the side, luckily, and I just saw this wall of humpback whale just jumping on my side and basically splashing back into the water. And I can't tell you what's happening next or what can happen when I will be engulfed and swallowed by a humpback whale. Nobody has ever experienced that. I'm pretty sure that they might spit you out again, but so far I can tell you. So this was the weather that we have to cope with in northern Norway. In the Arctic in January, you can experience, well, storm and a lot of big waves. And most of the days we actually weren't able to leave the port because the waves are so high. That's another expedition that I did that we stay in Nuremberg, in the southern part. There is a deep well. It's basically a pit, a deep shaft with water on the bottom. And this pit is about 800 years old. It's the castle of Nuremberg. Everything was destroyed during the Second World War except this well. So we worked together with archaeologists and scientists from the university in Nuremberg and Kiel to find out what's lying on the bottom. And you can see here, this is a shot into that shaft. And when you land on the bottom, 50 meters deep, you have water that is basically on an area that's about the size of your shower cabin, probably. And that's where you have to work. So most of the people that are still jealous, maybe when I tell them what I'm doing, they get less jealous and they like to be in a warmer place and a bit more comfortable space. We also do cave diving. We did 4 years of cave diving in Mexico. They have an incredible amount of treasures underwater because the Maya lived there, this people, and they lived in these ruins, but they also had these sacrifices and victims that they pushed into the so-called cenotes. It's a water pit in the jungle of Mexico, and I'm going to tell you later on what we found in these places. We also use submarines. This is the German submarine Jago. It's the only manned scientific submersible that we have in Germany. It can go down to about 400 meters, and it was used for a lot of different expeditions. This was in northern Norway as well, when we did experiments at the cold water corals off the coast of Norway. So I have a few topics that I want to address here. And the first one is advances in diving equipment, because it still sounds like a pretty analog process that we have here, diving. It's not suitable. We are not suited, or we are not made for living underwater, so we have to use equipment. And this equipment gets way more sophisticated over the years because it has been made a lot of progress to build this equipment. This is what it looks like about 100 years ago. Helmets and these lead shoes that you see on the left side. It looks a bit like 20,000 Leagues Under the Sea, Jules Verne walking on the seafloor and doing scientific stuff down there. Today, we have, of course, a proper diving equipment. Some say that scientific divers still use that old-fashioned equipment. That's, in some cases, definitely true. But I work with a company called SUBMARIS. I founded it with 4 of my friends. And that's the equipment that we use today. It's modern diving equipment, and it's standardized. And that was, for me, the most important part in developing a proper diving equipment and in addressing those scientific questions that we have underwater. When you have to think what you're doing underwater, when you have to think about diving, then it doesn't work. You have to be completely free, and that's why we use that kind of equipment. Everything is standardized, and everybody uses the same technique and the same equipment. I could easily use the equipment that my buddy has. I know where the hoses are, I know where the lamp is, I know where the regulators are, and this makes diving extremely safe and very much fun. And it's pretty efficient to work with this kind of equipment underwater. So whatever we do, if we dive with sharks, there was a production, a nature documentary that we shot on the Azore Islands. whatever we do, if we dive with sharks, we use that equipment. If we dive at a wreck in the Caribbean, that was done with the university in Kiel, we use the same equipment. It's, for me, some kind of a standardization, a unification of diving procedures that make this activity pretty safe. This is deep in a cave in Mexico. Sometimes we do dives in Mexico for about 3 or 4 hours, and we venture deep into the caves because that's where those skeletons are found. Human skeletons, but also animal skeletons that I will show you later. We have to do these kinds of dives. Here you can see 3 divers in a cave in France. They all use the same equipment, and they all use these propulsion vehicles called scooters. It looks a bit like James Bond, and probably you feel like it when you use it, but it can help you to go much, much deeper into caves, to circle wrecks, to go deeper than you were able before. And this is also a progress that has been made over the years to develop that equipment that we use now to do science underwater. So we come to the first topic that we have addressed over the last years. About 10 years ago, scientific divers only took samples. They were just scooping up a little bit of mud. Maybe they took a picture of a fish, or they were collecting corals. But this is a new address that we have today. It's the visualization of shallow seafloor. It's very important because the European Union wants to have a good protection of what they have in the ocean. We have the water surface, we cannot penetrate, we cannot see through that water surface. We have to go into the water, we have to dive, we have to use submarines, but also scientific divers. And the problem is, whatever you find down there, you can only see maybe 2 or 3 meters. The visibility in the Baltic Sea, but also in the North Sea, is pretty bad. 0.5 meter sometimes, 1.5 meters, 2 meters. So you can only see little bits of that ocean floor. This is a side scan image that was done by geologists. They have a proper idea how deep that is and how the seafloor looks like, but they don't know what's down there. We were working for the European Union for the last 2 years and trying to find a way to visualize that part of the seafloor that we actually see as divers. Because for politicians, they cannot imagine how the seafloor looks like. We can. And we have found a way. It's the so-called photo mosaic. This is basically when you have a pretty bad visibility in the Baltic Sea, maybe 1.5 meters. You can see all those backscatterings, all those particles in the water. But there's an interesting rock. And this interesting rock is part of a reef that is well protected. And we need to develop a method to actually show these reefs. So we used photo mosaics. It's like a satellite image, but it was done by 2 by 2 meters. So each of that square is 2 times 2 meters. So the whole is 100 square meters, 10 times 10 meters. And I used those pictures. I took them using markers that were basically dividing that grid into smaller squares and put them together in Photoshop. It's a very labor-intensive technology. There is no program. There is one, but it doesn't work underwater very well. So we had to work as pioneers again to use that photomosaic underwater. And what you can see here is the seafloor. You can never see like that because the visibility is just too bad. Here on the top left, there's a diver. Just to put in as a scale, this is about 2 meters long. And the visibility is so bad that you never can have the whole area for yourself. This is a big rock, and all that darker space, that is part of the reef in the Baltic Sea that is pretty diverse in species. So it's a very important part of this ecosystem that we have in the Baltic. This is another reef, and you can see here more than 50–60% of the seafloor is covered in rocks, and they are completely overgrown. A very important ecosystem that we use, and we use those images to actually address that problem, to visualize the seafloor and to protect these environments. Ocean floor monitoring is basically the same idea. It's just in a wider range. You have the same image, and of course, these people know now 10 times 10 meters is about that size, how it looks like, what lives down on the bottom. But they have no idea how it looks like on the right and the left and so on. It's very, very difficult to do these photomosaics of a larger scale. But what we can do is monitor that area, that seafloor, with scooters and with cameras. What you basically do is you have a line 2, 3, 4 kilometers long, and you use different and sophisticated camera techniques to find out what lives on the bottom. This is one of those scooters, and you can see here there's a camera in the front, and there's a big camera on the top. The little camera in the front we used to make videos, continuous video monitoring of the seafloor, and the big camera on the top we used to make high-resolution pictures of stuff that we saw on the bottom, like those rocks, what lives on those bottoms. This diver was in the water for about 2.5 hours, so it's pretty long dives, and you're pretty exhausted after you did that. And he covered about 2.5 kilometers. That's not too much, but it's way more that has been possible over the last 10, 20 years. So we are pioneers in this area of monitoring the seafloor, and mostly shallow seafloor. Of course, there are research ships that can go in the open ocean, can do a lot of deep sea research. We don't want to do that. We are focused on that shallow seafloor where research ships can't go. We developed this towed cam that was basically towed behind the ship. So there's a camera here, that low box, that blue box, and there's a light in the front. And the signal gets transferred to the surface where we can actually control the depth of the camera. This is the system. You have the boat, and if it's a nice day, then you have a calm day in the Baltic Sea. And on the lower right, you have the camera, which basically sees what you can't see on the sea floor. And again, this is not very easy work. You can imagine when you look and watch that monitor here, this green rectangular area here. That's the picture of the camera that gets transferred to the ship. You get seasick pretty easily. We had everybody of us was seasick at least 1 or 2 hours every day, just staring at this screen and controlling the camera just by pulling it up and down. What we want to do now is to connect the GPS data from the ship with the video that we have from the camera. And now it gets pretty interesting. We have a GPS and we have a recorder that records these GPS information all the time. Now we have, watching that video that we just recorded, that shows interesting areas, like here on the lower right, sandy seafloor with a lot of rocks. Here on the upper left, nice rocks that are completely overgrown with interesting stuff that we want to see later. So we needed the GPS position of those things that we saw on the bottom. How do we do that? Well, GPS and video, on the first glance, they are not connected at all. There's no connection between the video from the tow camera and the GPS system on the ship. But there is one, and it's the time. Time is crucial for GPS positioning, but also for the video, because we have a time code on that video. So now imagine we start the video at about 2 p.m. We drop the camera onto the bottom. We record the GPS at the same time, and of course the time just runs. Watching that video later on, we find, let's say, these rocks on the video. Now we want to know where they are. In the process of towing the camera, we cannot stop the camera. We cannot take the position. We have that continuous recording of the GPS. We know that the time code of the video is 4 minutes and 25 seconds. So we know the time when the camera was exactly on top of those rocks was 2 p.m. and 4 minutes and 25 seconds. Now we can go back into the list of the GPS and can exactly tell the position of those rocks. What we did was developing a software together with software engineers that made that possible. We have different shortcuts that we press while we watch that video. You basically have a computer screen, you just watch that video, and you say, okay, F9 is no muscles. You press F9 when you see sand. Suddenly you see a big rock. You press, let's say 4 is 1 block, 6 is more than 5 blocks. So we have these shortcuts to address all those findings that we have on the seafloor. Pretty interesting, but it's pretty boring when you watch like 10 hours of video of seafloor when nothing's happening. But every now and then in the Baltic Sea, you have these nice reefs. So what we have in the end is a video that still stays like that. And in the end, we have a list, an Excel list, which tells us the time code and the findings that you have at the same time. And with that, it's possible to connect the video with the positioning system. And it was done for the first time. There's nothing off the shelf that was able to do and to deliver that job. So we had to develop that software for ourselves, together with those engineers. And what we have now is a very powerful tool to see the seafloor and to have an overlay of rocks, seagrass, fish sometimes, wrecks, if you find wrecks. And this is very important for the politicians. We also work for the state agency for environment in northern part of Germany. And they are very interested in that software because it gives them a powerful tool to address these problems. What we so far did was to map eelgrass meadows on the seafloor. It's a very nice ecosystem whenever you go to the North or the Baltic Sea. Take on your dive mask, your snorkel, and just snorkel in that beautiful eelgrass because it looks very nice. And what you basically see here is all the green stuff is healthy eelgrass, but you have that red thing that is basically devoid of sea and eelgrass. And because there's a sewage outfall, what happens now is probably that this sewage outfall gets prolonged, and they made it very, very much longer to put it in the deeper water in the blue here, because then the sewage outfall is not transported back into the eelgrass where they die off. So this was one of the results that we had over the last years, to monitor the seafloor on a large scale, much larger than was possible with this photo mosaic. But we're still beginning to develop that software and to improve it over the years. 3D modeling was a very new thing a few years back. It's now made available to almost everybody, but still underwater, it's a very challenging subject because you have to cope with this bad visibility over the years. This is an underwater archaeologist from the university in Kiel. So we find a lot of things still in the German waters. Like this is a wreck of a submarine off the coast of Helgoland. It's actually the last submarine that is still on the ground from this First World War in German waters. So it's now over 100 years old. It's completely overgrown in beautiful sea lilies and sea anemones. So this is one finding that we have in the North Sea, but it's also smaller stuff that we find in the Baltic Sea, because the Baltic Sea was a place where a lot of trade was happening. And this is a pot that is about 250 years old. The problem is with all those findings, you find them on the seafloor, you might have a position, but what do you do with it? Bring it back up to the surface? That's where the oxygen rules. Of course, we have 21% oxygen in our atmosphere. That kills everything that was lying underwater for such a long time. This pot would probably be destroyed within a month or a year when it came into contact with air. So what we do is trying to find a method. We can leave those things on the seafloor, but still investigate it later on when we come to the surface. And 3D modeling came very, very handy when we used it for the first time. This is again in the Mexican caves in Yucatan. It's unbelievable what you find in those caves. You not only find Mayan remains, like this pottery that's about 1,500 years old from these Mayan times, but you also find skulls. You find prehistoric settlers in Central America, skeletons that are about 12,000 years old. Some of the oldest findings that you have on the American continent are still found in these Mexican caves. And one of those cenotes we were able to see ourselves. We got a special permit from the Mexican government. And this on the left side is the entrance. It's a hole in the ground, in the jungle, maybe 1 square meter, tiny. And then it continues for 13 meters. You have to upside down all your equipment. And that's on the right side. You can see how it looks like from below. You have water, so half of that cave is actually water-filled. And we have to lower all the equipment, have to put on this standardized equipment. And you can already see that there's a little mountain here underneath. And that's where we found the first skulls. The whole cenote, the whole cave, is about the size, maybe 4 times that area that we have here, the audience and the stage. So very small. We found 125 skulls and skeletons. We had no idea how old they were, because some of them look like they were thrown into that cave about 2 weeks ago. Pretty new, very well preserved. The problem is these things are much, much older. So digging that out and bringing it back to the surface, it would destroy those skulls. So we had to find a way, together with the Mexican archaeologists, to preserve those skulls, to leave them on the ground. And what we did is basically taking pictures, loads of pictures, with a normal two-dimensional camera, like a normal camera, single lens reflex, or a mirrorless, whatever you have. And we worked together with software engineers from the university in Kiel. What they do is computing a 3D model out of that pictures that I delivered. And you can see here already, these are the position of my camera pictures that were modeled afterwards. And you can already see that the skull itself is pretty detailed, but it gets even better. Here you have, yeah, it works, a video of that skull that I took pictures of, later on computed as a 3D modeling. It's impressive because it shows all the details that you need to have to investigate, to measure those, this skull, and to tell that it was a Mayan skull, because the form was pretty different that you have today. I would love to print this skull out. It wasn't possible over the last 5 weeks because I wasn't in Germany. Is there another? Yes, here it is again. So this is the skull that we have, but it's not a picture, it's a 3D model, and we can go so much further into that skull. It's impressive because the pictures that I have from my camera are so have a high resolution that you can use all that resolution to create this 3D model. Pretty sophisticated stuff for me. I don't know exactly how it works. I just deliver those pictures and can work later on with the archaeologists and the underwater scientists to tell more about what happened in these in that cenote. This is one of those skulls again, and you can already see here these details on the forehead. If you had, it's pretty detailed and well preserved in that model again. So what you have here is filed teeth. I think you can't see it from the back. This guy has filed teeth. Even if it looks like it was thrown into that cave about 2 weeks ago, it's 1,800 years old. So it comes from the classical Mayan times. They had like this beauty sign, it was filed teeth. It's impressive what you find in the Mexican cenotes and what you still find today. This was the only skull we had to touch. All the other skulls still remain on the bottom of this cenote, where they are well preserved and protected. They will still be there in about 5,000 years when we don't touch them. This was the only skull we had to touch because we wanted to date it. We wanted to tell how old the skull is. And to do that, no 3D model can help. You have to take a sample of the teeth and bring it back into a laboratory where you can have the C14 method, this carbon-14 method, and can actually tell how old the skull is. And this skull is 1,800 years old. So now I told you a little bit about the challenges that we have to meet during our underwater adventure. We still work as divers in that environment. It's pretty wild, it's pretty rough, but it's a lot of fun. But we have developed a lot of different technologies over the years. In some areas, we're actually pioneers because we have a lot of problems that we have to address underwater to find out more about the secrets that are still lying on the seafloor. If you have any questions, please feel free. Thank you very much.
Thank you very much, Uli. That was pretty exciting, kind of Google Street View underwater.
I wish it was possible, yeah.
When you started out becoming a biologist, that technology wasn't around yet, right?
No.
So how do you get used to using this? I mean, now you seem more like a technologist than a biologist.
Well, I'm still fascinated about everything that has to do with technology. And together with science or diving, it gets even more exciting because I like to use these tools underwater to answer those questions that we have in science.
And do you actually help to develop the technology? I mean, do you get a say in what you need underwater to actually do your science?
Yes, when it gets to camera equipment, we actually can, because we're working together with some camera manufacturers and camera companies. I can address what I need as a scientist. But of course, the amounts of camera that camera companies sell to scientists is pretty low, probably, compared to the main market. When it comes to this 3D modeling, yes, we work together with the software engineers because we know how it looks like underwater and can tell them what works best. And they, on the other hand, can actually tell us what they need. So it was a pretty, like an equal cooperation that we had there.
Thank you very much for that really exciting talk. I thought it was a great idea to see how you can use technology those days to actually still explore the planet we live on. We seem to be talking a lot about e-currencies and data, big data stuff, and obviously we haven't discovered our planet yet, so I think that was a pretty good thing. We'll see you again here on stage tomorrow, right?
Yes, at I think 2:45, so in case you know somebody who is interested in underwater technology, feel free.
And make sure you bring the picture from that humpback whale that almost swallowed you.
Oh, that's right. Maybe I'm going to show you tomorrow. Yeah,
That would be cool. Thank you very much, Uli.
Thank you.